In this simulation video, we will be showcasing JOMSIM simulations representing the global semiconductor supply chain amidst geopolitical tension over chips and technological prowess between the United States and China. Let us begin by understanding the geopolitical context behind this simulation. For many years, the United States was the dominant player in the global semiconductor supply chain. However, that has been quickly fading away, with China's brazen moves made to steal semiconductor-based intellectual property, making great and successful progress. As a result of China's outright commitment of intellectual property theft, the United States has taken several countermeasures to restrict chip exports and IP access to China under the incumbent Biden administration. Now that we understand the context behind the simulation, let us look at the simulation design. In modeling this, we designed two simulations, past and future. They represent the global semiconductor supply chain network before and after the geopolitical intervention. In the past global semiconductor supply chain simulation, all 5 regions are interconnected. With the intervention of IP theft from China and sanctions from the United States, the future global semiconductor supply chain is as such, where China is cut off from USA and East Asia. In simulating the semiconductor supply chain, we use a simple 5-stage process: extraction, processing, manufacturing, assembly, and distribution. Each region has their own combination of processes and would import and export from each other. Using this framework, the simulation is designed with the 5 regions interconnected between their supply chain processes on the world map. This is the past flow, where China mainly only supported the processes of extraction, assembly, and distribution, and has trade links with East Asia and USA. On the other hand, the future flow is set up based on the assumption that as China has stolen intellectual property from the United States, it has the means to set up its own end-to-end semiconductor supply chain. Consequently, the United States and its East Asian and European allies cut their ties off from China and, by extension, Southeast Asia. Now, let us look at both past and future simulations on JOMSIM. Here is the past simulation, where all the regions are interconnected. We can see the goods passing through the 5-stage supply chain process in each region. The goods also move in and out of the regions as they are, being imported and exported. The total profit and loss values of each region for the past simulation are being calculated and logged as follows. And now, for the future run. Here, we see that China has set up its own end-to-end supply chain production of chips while having its trade links cut off from USA and East Asia. This new simulation shows the regions being divided into 2 separate entities, one with China and Southeast Asia, and the other with USA, East Asia, and Europe. The total profit and loss values of each region for the future simulation are being calculated and displayed as follows.
To analyze the impact of the geopolitical intervention on the economy, we run the simulation for 1,000 years and collect data of the profits of each region in the simulation. The data is then processed and cleaned for data analysis and statistical tests in R. This is the equation we are using to determine the total profit of each region. It is essentially calculated by summing the sales revenue, production costs, export revenue, and import costs. Now, we proceed with the data analysis. As we are analyzing time series of monthly profits, we first remove the initialization bias. Due to the large variance, we use a batch means approach to analyze the data. We split the time series data into 1,000 batches of 12 data points. so each batch represents 1 year in the simulation. By applying a batch means approach to analyze the time series data, we are essentially analyzing the average monthly profits of each year in the simulation. With the 2 samples of data of past and future, we now want to determine whether there is a significant difference in annual average monthly profits for both past and future simulations. Treating each year in the simulation as independent, we conduct 2 sample t-tests for all the columns in the dataset. Through the statistical tests, we arrive at the conclusion that all regions except Europe have been impacted with significant losses and gains. While China and Southeast Asia benefited from the intervention with a significant increase in profits, USA and East Asia suffered significant losses. Looking at the total monthly profits across all 5 regions, we also observe a significant increase in profits, showing that the global economy has overall become more efficient as it is now much cheaper to produce and manufacture chips from China. These results are expected and can be understood through the changes in trade links within the regions. However, it must be noted that these results should be taken with a pinch of salt due to the unrealistic nature of the simulation. Nonetheless, it can be used to understand how disruptions in supply chain trade links can have significant impacts on the economies of different regions in the global supply chain.